All right, we have the square root, right? Square root. In the square root, what is the leading term?
X to the fourth.
X to the fourth, yes. So since the square root on top of it, we have to carry it with the term. We ignore the negative 8 as we ignore the 6x minus 1. So now the denominator, which is 3x squared. The numerator, you see they have the square root of x to the fourth. What would that be if you rewrite it in the simplified form? So this is x to the fourth all to the power
1/2.
Finally, what should we get? X to the second, right?
Yeah.
X to the second. Keep an eye on the second here. This is an even number. Even number. We're gonna look at different one eventually. So x squared over x squared reduce. That means eventually it's gonna be 1/3. So the limit as x approaches infinity of this function gonna be the same as when we look at the limit of the leading term, root x to the fourth over x 3x to the second, x approaches infinity, or basically we find the limit as x approaches infinity of the more simplified or adjusted form of the leading term, or just 1/3. Okay, 1/3. 1/3 is a real number. Now we get one of the horizontal asymptote y equals 3. Okay. Similar way for the limit as x approaches negative infinity. So we're going to have the same way, limit of 1/3 or just 1/3. Okay. Even number, even number. So the x value that if we think about the number of the x is negative. But the one that we are dealing with, the power is even power. So we assume like negative sign when you raise to the second power, raise to the fourth power, they all become positive, right? Okay, so this problem, not too bad. We can be careless about the negative sign for the even power, So both of them will give you the same horizontal asymptote. Question for part D. No? Yes? Okay. Gonna move on to another case. Excuse me. All right, next one. Consider the leading term again. The numerator has only one single term, not bad. How about the denominator? Leading term, oops. Right? Within the cube root, the greatest power would be the power 3. There you go. So it's the cube root of 64, x to the third. This time we have an odd power. Okay. The simplified form of the bottom is what? What is the cube root of 64?
4.
4. And the cube root of x to the third gonna be x, right? Gonna be x. Came out to be the same. Since this is another odd and odd, simplify 2/4. That gives us 1/2. Okay. So the limit of infinity gonna be 1/2, the same as at negative infinity. So the horizontal asymptote is y equals 1/2. Okay. Another example. So this is the combination of odd and even. How about I take away this one I'm gonna clean up and I'll post more information or record another example later on with this term in. Okay, I try to keep it gradually in the um, kind of the flow from different cases from the not too bad and add more of the complication. So for this one, part F, if we have 8x to the third plus 2, all divided by square root 16x to the 6 minus 1. The leading term, the numerator, 8x to the third, okay? Denominator, the numerator has a power, the odd power here. The denominator, the leading term, very obvious, right? Square root 16x to the 6. Inside here is the even power. The top is x to the third divided by square root 16. We all know is 4. Okay, is 4. Square root of x to the 6. What do we get?
3.
X to the third power, right? But x to the third power, because whatever the number raised to the power 6, this one come in as whatever number is to raise to the 6th power, which is the even power. The quantity x to the 6 return to positive sign because the radical, the restriction is positive or non-zero or non-negative, right? You cannot take the square root of negative number. So the number comes in, whatever it is, you raise to the power 6, is transformed into the positive number, take the square root, and then take the square root of x to the 6, gonna be x to the third, but this x to the third gonna be positive inside. Question, why I put the absolute value? Because I'm gonna protect the case that if you start with the negative number, you're gonna do the negative number raised to the power 6 before you take the square root. Once it gets out of the square root, it's already changed the sign to the positive, which is the absolute value of that number. Does it make sense? Okay, we'll see. So this one will be 8 over 4, which is 2, x to the third over absolute value of x to the third. Okay? All right, I will keep it as absolute value because we have to consider the negative quantity that comes in. Okay, so the first case limit at x approaches infinity gonna be the limit of 2x to the third divided by absolute value of x to the third. X approaches infinity. For x approaches infinity, so x is positive but very large, right? Very large. So then we can ignore the absolute value. Does it make sense? So x to the third cancel. We get the limit value as 2. So we have y equals 2 as one of the horizontal asymptote. This is the right end. This is the right side of the graph. Okay, because it approaches infinity. And next, the left graph. We take the limit. The leading term, we already clean up into the simplified version of the leading term. We have the limit of 2x to the third divided by absolute value of x to the third as x approaches negative infinity. Negative infinity. That means my x or your x, that's starting with the negative inside. Okay, negative inside. So you see, if you come in the top, negative to the third power, you have what? Negative, right? Negative. You come in the denominator part, you come in as negative. You raise to the third power, you take the absolute value, it becomes what? Positive inside. If you are confused, you can look back at the original denominator here. you put x negative in, negative to the power 6. What happens to the power 6? It changes to the positive inside, right? And you take the square root, it will come out as a positive as a result of the square root of that power 6. Does it make sense? Okay, we'll see. So, but excuse me, for x approaches negative infinity, we have to look at more detail within the content. As we see the limit, the top goes to negative, the bottom goes to positive. The sign, they are not the same, but the power are the same. You can simplify it, but when you simplify the number, for example, you have negative a divided by a. What do you get? What do you
Negative.
get? Negative 1, right? Negative 1. Therefore, the limit of this is 2 times negative 1 or negative 2. Negative 2. So we have another horizontal asymptote y equals negative 2. In this case, on the right side, the graph approaching the line y equal 2. And then the left side, the graph approaching the line y equals negative 2. Someone has question? Why is it absolute value? Because you started with the negative inside. You take the square, you raise to the power 6. The negative becomes positive. The sign already switch, which is the absolute value of the original one. Then you take the square root. You can take the square root when the quantity is not negative number, which is opposite of whatever that you came in. So the final result of that term will be opposite of the original sign, which is the absolute value of the negative. That's why it returns positive. And we have to keep the absolute value for that quantity, because if it comes in as negative, it gets out as positive. Okay, that's the explanation about using the absolute value sign. And for this kind of problem, you can use the graphing calculator to verify, adjust the window, the x min, x max to be very large, like kind of do the zoom in, zoom out to see what happens to the left end, what happens to the right end. So that's another way to verify. But this is the way to analyze it without using the calculator. By using the limit